Hi, everyone. All right. I want to do an example for a one sample T interval. This has to do with means. And so be careful. Do not confuse means and proportions. When we're looking at means, we are looking at quantitative data. So let's read the question. It says Rocky Mountain Airlines Flight 441 flies from Denver to Albuquerque each day at 8 a.m. The flight is listed as taking 58 minutes on average. A random sample of 9 of these flight times rounded to the nearest minute is given in the table below. All right, so the first thing is to point out the important information. In this case, we are not given statistics, we are given a list. So we're going to have to find our mean and standard deviation from the list given. Now be careful. The 58 minutes that's given in the problem is not a sample mean. This is the claim of what the company makes, that it's on average 58 minutes that this flight takes. So we're going to go ahead and enter this sample into our calculator. So I already have it entered into the calculator. It's important to name your list. I named it flight. Now I'm going to open a new page. So Control, Add Page. And from here, I'm going to go to Menu, Statistics, Confidence Intervals, and then I will go to number 2 here, T interval. Once we get to T interval, you have the option either to enter data or stats. Stats means that they gave you the sample average, also gave you the sample standard deviation. But we do not have the statistics, we have the data, and that is our list. So I'm going to keep it at data. And then I'm going to enter the list. We name that, or I named that flight. So, and we want a 95% confidence interval. So I'm going to keep that at 95% and then press OK. So all my information shows up here. I have my lower bound, my upper bound. Notice that also what is calculated here is the mean right here. We have the mean. And so what I did is I uploaded this screen. So as if having your calculator in front of you. The first thing we're going to do is we're going to state and check the conditions. Number 1, it states it's a random sample. So I have that checked off over here. Number 2, do we have a sample size that's greater than or equal to 30? We do not. Our sample size is n equals to 9. So that is a bit of a problem. So unless the problem states that your sample was taken from a normally distributed model, which it does not, then what you need to do is go back to your calculator, since we already have the list entered, and I'm going to graph the data that we entered to see if there is any skewness or any outliers present, because what we want to show is that our sample appears to be somewhat normally distributed. So I'm going to go ahead and add a page. We're going to go to add data and statistics. So that's going to display the values we entered from our sample. I called it flight, so there it is. Now the kind of plot that I want to do is I'm going to go to plot type. You can pretty much choose a box plot, a histogram, or a normal probability plot. So if you look at a box plot, you can see that there are no apparent outliers. Best display would be a normal probability plot. And from that, when it shows an approximate straight line, then our normal probability plot indicates that this is somewhat normalish. So looking at our second condition, we don't have our sample sizes greater or equal to 30, but what we do have, and I cut and paste here, is a normal probability plot. So using the normal probability plot, we see the data shows a somewhat straight line, which shows approximately normal distribution. Going on to the third condition, we want to show that a population is greater than or equal to 10 times n. 10 times 9, which is our sample size, is 90. There are more than 90 flights in our populations. We will say conditions met, and we will use a one-sample-T interval. From here, because we are using a T interval, I'm going to find my critical value. In this case, it's a T critical value. In other words, a T score. So 95% in the middle, which means 2.5% left on either side. We're going to go ahead in our calculator. We're going to do inverse T 0.025, or if you use a table, that will work as well. But the important thing here is to enter the degrees of freedom. So you should always enter your degrees of freedom under your mechanics. So we will say that our degrees of freedom is equal to 8. That would be n minus 1. And then using our formula, it's important to write down the formula. You could either choose to write it in words or symbols. I would stick to words because if you mess up the symbols, you will get points taken off. So statistic, which is, by the way, given on your formula sheet, statistic plus or minus your critical value times the standard deviation of the statistic will give you your lower bound and upper bound. Our statistic is X bar, which is the sample mean, plus or minus our critical value, which is our T crit, which we found by going to inverse T, is 2.3. So our critical value is 2.3 times the standard deviation of the statistic, which happens to be our sample standard deviation divided by the square root of the sample size. So our sample standard deviation is given right here. And all we need to do is enter those numbers in the formula and use the lower, which I have highlighted in yellow here, and the upper bound. Once we have that entered, we can then go on to our conclusion, which basically states we are 95% confident that the true mean flight time is between 57.70 minutes and 60.96 minutes from Denver to Albuquerque. Now, a follow-up question on this is to state, does the interval give you reason to suspect that the claim of 58 minutes is false? Now, let's take a look at our interval. Does 58 minutes fall between 57.7 and 60.96? Yes, it does. Now, since the 58 minutes lies in our interval, we can answer something like this. No, the interval does not give us reason to suspect that the claim of 58 minutes is false, since 58 minutes falls within our interval. So this is how you would present all your work.